Ever wondered what keeps a giant metal bird in the sky? Let's unravel the mystery of flight. To the forces of flight. Flight is all about balancing four key forces: lift, weight, thrust, and drag. Each plays a crucial role in keeping airplanes airborne. Lift is the force that opposes weight and is generated by the wings. It's what helps the airplane rise into the sky. Weight is the force that acts downwards due to gravity, pulling the airplane towards the earth. Thrust propels the airplane forward and is produced by the engines. It's like the pedal power on a bicycle. Drag is the air resistance that slows the airplane down, similar to the feeling of wind against your face when biking. For an airplane to fly, lift must equal weight and thrust must overcome drag. It's a delicate balance. Airplane wings are designed to generate lift efficiently by their shape and angle, utilizing Bernoulli's principle. Aerodynamics, the study of how air interacts with moving objects, is crucial in designing planes that fly smoothly. Understanding these forces reveals the elegant dance that keeps airplanes in the sky. If you enjoyed this breakdown, hit that like button. Understanding lift and its role. Lift is the force that directly opposes the weight of an airplane and holds it in the air. It is generated by the wings as they move through the air, creating a pressure difference above and below the wing. Wings are specially designed to create lift. Their shape, known as an airfoil, is crucial for generating the necessary pressure difference as air flows over and under the wing. Bernoulli's principle explains why lift occurs. As air moves faster over the curved top of the wing, it creates lower pressure compared to the slower-moving air beneath the wing. Newton's third law also contributes to lift. As the wing pushes air downwards, the equal and opposite reaction pushes the wing upwards, contributing to lift. The angle of attack is the angle between the wing and the oncoming air. Increasing this angle increases lift, but too high an angle can cause a stall. Lift can be compared to a hand out of a car window, tilted to catch the wind, a kite catching the breeze to rise against gravity. Factors affecting lift include wing shape and size, speed of the aircraft, air density and temperature. Without lift, flight would be impossible. It allows aircraft to rise into the air, stay aloft, and is essential for maneuvering. Understanding lift is key to understanding flight. Next time you see a plane soaring through the sky, remember the incredible role lift plays. If you're finding this fascinating, a quick like would be amazing. The impact of drag. Drag is the force that opposes an aircraft's motion through the air. It's essentially air resistance, working against thrust, and it must be minimized to improve flight efficiency. There are two main types of drag: parasite drag, caused by the aircraft's shape and surface; induced drag, generated by the creation of lift. Parasite drag increases with speed and is caused by factors like skin friction and form drag. Streamlining the aircraft can help reduce this type of drag. Induced drag is a byproduct of lift. As lift increases, so does induced drag. Engineers design wings to balance this trade-off, optimizing for efficient flight. Think of sticking your hand out of a car window. The force you feel pushing back against your hand is similar to drag on an airplane. Aircraft are designed with sleek, aerodynamic shapes to minimize drag. Features like winglets and smooth surfaces play crucial roles in reducing air resistance. As speed increases, so does parasite drag. Pilots and engineers must find an optimal speed that balances thrust and drag for efficient flight. The concept of drag isn't limited to airplanes. It affects cars, cyclists, and even swimmers. Understanding drag helps improve performance across various fields. Reducing drag is crucial for fuel efficiency. Less drag means less fuel consumption, which is vital for both economic and environmental reasons. If you're finding this useful, a quick like would be amazing. Thrust, powering through the sky. Thrust is the force that propels an airplane forward, overcoming the force of drag. It is generated by the engines and is essential for takeoff, maintaining speed, and controlling flight direction. Airplane engines, whether jet or propeller, convert fuel into energy. This energy creates thrust by pushing air backward, propelling the aircraft forward. The engine's design and power output are crucial for efficient thrust generation. Thrust is a practical application of Newton's third law. For every action, there's an equal and opposite reaction. As engines push air backward, the plane moves forward, demonstrating this fundamental physics principle. Imagine riding a skateboard and pushing back on the ground with your foot. The skateboard moves forward, just like an airplane moves when engines push air backward. This simple action mirrors the concept of thrust. Different types of engines provide thrust for aircraft: jet engines, which are common in commercial airliners; propeller engines, often found in smaller planes; rocket engines, used in spacecraft and some high-speed aircraft. Thrust must constantly overcome drag to keep an airplane moving forward. Drag is the air resistance that opposes thrust, similar to the resistance you feel when running against the wind. Aerodynamics plays a significant role in optimizing thrust. Streamlined aircraft designs reduce drag, allowing engines to use less fuel while maintaining necessary speed. Efficient aerodynamics is key to effective thrust. Thrust varies during different flight phases. During takeoff, maximum thrust is needed to lift off the ground. In cruising, consistent thrust maintains speed and altitude. For landing, thrust is reduced to slow down the aircraft. Innovations in engine technology aim to make thrust generation more efficient and environmentally friendly. Electric and hybrid engines are being developed to reduce fuel consumption and emissions. What are your thoughts on this? Let me know below. Weight, the counterforce. Weight is the force of gravity pulling the airplane toward the Earth. It's a constant downward force that must be overcome by lift for the aircraft to stay airborne. Gravity acts on every part of the plane, including the passengers, cargo, and fuel, contributing to the total weight. This invisible pull is what challenges the plane to stay aloft. For an airplane to maintain a steady altitude, the lift generated by its wings must equal the weight pulling it down. This delicate balance is key to stable flight. Wings are designed to generate lift, countering the weight of the plane. Their shape and size are crucial in determining how effectively they can perform this task. Weight distribution affects stability and control. Properly balancing weight across the aircraft ensures it can be safely and efficiently maneuvered. Think of weight in flight like carrying a heavy backpack. Just as you adjust your posture to balance, pilots adjust controls to manage weight and maintain flight. Fuel is a significant part of an airplane's weight. As fuel is burned, the plane becomes lighter, affecting balance and requiring adjustments during flight. Takeoff is a critical phase where overcoming weight is essential. The plane must generate enough lift to counteract its weight and achieve liftoff. Modern aircraft use advanced technology to monitor and manage weight distribution, ensuring optimal performance and safety throughout the flight. Wings, engines, and aerodynamics. Wings are crucial as they shape the airflow, creating lift. Their curved upper surface and flatter bottom exploit Bernoulli's principle, causing air to move faster over the top and slower underneath, generating lift. Engines propel airplanes forward by pushing air backward. This action-reaction principle, based on Newton's third law, ensures the plane moves ahead, overcoming drag and contributing to lift. Aerodynamics is the study of how air interacts with moving objects. Streamlined shapes reduce air resistance, allowing for smoother and more efficient flight. It's why airplanes and birds have sleek designs. Lift is generated mainly by the wings as they slice through the air. It's the upward force that counters the plane's weight and is vital for keeping it airborne. Drag is the air resistance that opposes an aircraft's motion. Minimizing drag through aerodynamic design improves fuel efficiency and speed, crucial for effective flight. Successful flight depends on balancing lift, weight, thrust, and drag. Pilots and engineers work to maintain this equilibrium for smooth, controlled flights. Aerodynamics isn't just for planes. Cars, trains, and even sports equipment use similar principles to enhance performance. Next time you see a speeding car, think about how it's cutting through the air. The interplay between wings, engines, and aerodynamics is a marvel of engineering. Each flight is a testament to human ingenuity and the mastery of natural forces. If you're enjoying learning about flight, a quick like would be amazing. Everyday comparisons to simplify concepts. Think of lift like flying a kite. When the wind catches the kite, it rises into the sky. Similarly, an airplane's wings catch the air, lifting it upward. This is how lift works to keep airplanes airborne. Imagine carrying a heavy backpack. The weight pulls you down, just like gravity pulls an airplane downward. Pilots must balance this force with lift to keep the plane aloft. Thrust is like pushing a shopping cart. The harder you push, the faster it moves forward. In airplanes, Engines provide thrust to propel the aircraft through the sky. Drag is like sticking your hand out of a moving car window. The air pushes against your hand, slowing it down. Similarly, drag resists the airplane's forward motion. Wings work like a paper airplane. When you throw it correctly, it glides smoothly. Airplane wings are designed to create lift, allowing the plane to fly efficiently. Engines are like a bicycle's pedals. Pedaling harder makes you go faster. Similarly, airplane engines generate thrust to move the plane forward. If you're finding this useful, a quick like would be amazing. Aerodynamics is like a streamlined car cutting through the air with ease. Smooth shapes reduce drag, helping both cars and airplanes move efficiently. Flying is like a tug-of-war between forces. Lift and thrust pull one way, while weight and drag pull the other. Pilots must maintain balance to keep the plane stable in the air. What are your thoughts on this? Let me know below. Harmonizing the forces of flight. The four forces of flight, lift, weight, thrust, and drag, must work in harmony to keep an airplane airborne. Each force plays a crucial role, and their balance determines the success of flight. Wings are designed to create lift by manipulating airflow around them. Their shape and angle are crucial for generating the upward force needed to counteract weight. Engines provide the necessary thrust to move the airplane forward. This forward motion is essential for the wings to generate lift, effectively overcoming drag. Aerodynamics ensures that the airplane's shape reduces drag and maximizes efficiency. Streamlined designs help minimize air resistance, allowing for smoother flight. Imagine the forces of flight as a balanced seesaw. Just as balance keeps the seesaw level, the harmony of lift, weight, thrust, and drag keeps the airplane steady in the sky. Pilots manage these forces by adjusting controls, ensuring that the airplane maintains balance and stability throughout the journey. Aircraft engineers meticulously design every component to optimize these forces. Key elements include wing shape and size, engine power and efficiency, overall aircraft design. Flight is a marvel of engineering and physics, showcasing the seamless interaction of forces. Understanding these elements enhances our appreciation for this incredible achievement. If you're fascinated by the science of flight, why not explore further? Your curiosity could lead to exciting discoveries. If you enjoyed this video, a like would be amazing.